Now let's look at another way we might describe a data set, and that's with how varied that data set is. So we're going to talk about measures of variation. Now the variation in the data set is how spread out the data values are. So some data sets would have very little variation. The data values are going to be packed really close together. Some data sets will have a lot of variation. The data values will be a ways away from each other. So a lot of variation. And then sometimes there's going to be kind of a medium amount of variation. There are multiple ways we can measure this spread or this variation in a data set. The range is probably the simplest. The range is the difference between the high value in the data set and the low value in the data set. So for example, if we have two groups of 6 people and they tell you how much cash they currently have on them. And group A, the people have $4, $8, $12, $15, $28, and $34. The range would be calculated by looking at the low value and the high value and subtracting them. And it's always the high minus the low. So that would be 34 minus 4, which would be a range of $30 because this was in dollars to begin with. In group B, you have 5 people with $8 and 1 person with $108. So the range would be 108 minus 8, which would be $100. So if we look at the range on the second group, group B, is much, much higher. It's $100 compared with 30. So you might say, well, group B has more variation in that data set. But let's be a little more careful here and look at it again. Group B has 5 people with the same value in their pockets, $8. And then one person had a lot more at 108. And it's that one person is very different, which is making this range very high. Remember, we talked about high values or really unusually high values or really unusually low values as being outliers. And just like the mean can be affected by outliers, the range can be very affected by outliers. So even though 5 of these 6 people had the same amount of cash in them, so there was no variation, because of that one outlier, our range ends up looking really high. And so we end up with a much larger range. So if you only look at range and you happen to have an outlier, that range may kind of skew your image of how spread out the data is. Now, officially, that data is spread out, but it's spread out because of just one data value, not the others. The others were all tightly packed at 8. Now the range is very affected by outliers, so sometimes we want to go beyond that, and so we're going to look at several other ways that we can talk about spread. And one of them is what we call the 5-number summary for a data set. The 5-number summary contains, just as it mentions, 5 numbers. The first number is the minimum, or the lowest number in the data set. The second is what we call the lower quartile, also abbreviated as Q1 or the first quartile. Then we have the median, which is our standard median, but the median technically can also be called Q2. We have the upper quartile, also referred to as Q3 or the third quartile, and then finally the maximum, which is the highest value. Now, I'm mentioning quartile a lot here. 3 of these numbers refer to quartiles. Now, let's talk about what quartiles are, and that's going to help us understand what the 5-number summary does. A quartile, or quartiles, split the sorted data set into quarters. So that's why they're called quartiles. They split the data set into quarters. Or if you think about fractions, that would be fourths. Okay. In particular, let's think about splitting something into fourths. A good way to do that in general is to go ahead and think about, first off, splitting something in half. So if you think about having a rectangular, like maybe a Hershey bar, candy bar, if you were to split it into quarters, you would first split it in half at the median. Then you would split the 2 individual halves in half. So you would take the lower half of the data and you split it up in half itself, and we call that Q1 or the lower quartile. Lower because we're splitting the lower half of the data in half. And then we can do the same thing with the upper half of the data, split it in half. That creates Q3, which is the upper quartile because it's the middle of the upper half of the data. Now, the median, so when we think about quarters, is actually referred to as Q2 because it is the second quarter, you might say. It's the boundary between the second and the third. So that's why we sometimes refer to the median as Q2. But it's more common because we talk about the median as the median. It's a terminology we use for measures of central tendency to just call it the median instead of Q2. Now, the other two numbers tell us the ends of the data set. So then you have the minimum and the maximum. So basically these 5 numbers are taking the data set and showing you what it looks like in terms of the quarters, the boundary of all 4 quarters. Within this 5-number summary, you can easily calculate the range because the range is going to be the maximum minus the minimum. And you're given that in the 5-number summary. And then we also extend that and talk about something called the interquartile range. Remember, the range is going to be influenced by outliers, which are often at the maximum or the minimum values of the data set. So the interquartile range is a way to avoid that. What we do is we only look at the middle 50% of the data. So we would be subtracting Q3 and Q1 to get the interquartile range. So it's basically looking at the middle 50% of the data. And it's the middle 50% of the data between Q1 and Q3 because you're looking, Q1 takes you a quarter of the way into the data, and then Q3 takes you a quarter of the way in the reverse way into the data. So if you take off the upper and lower 25% of the data, you're left with the middle 50%. So the interquartile range eliminates the high and low values of the data set. So it eliminates outliers. And what you do is you concentrate on where your middle 50% are. And so that can be one way of looking at spread of just the middle part of the data set. Now, quartiles can be calculated slightly different ways, but I'm going to follow the method that our textbook uses, which is a fairly common method. And the way we calculate those upper and lower quartiles is just the way I described it here. You're going to look at the lower half of the data and look at splitting it in half, and the median of the lower half of the data will be Q1, or the lower quartile, and the median of the upper half of the data will be Q3. The issue with this really has to do with if the median is an actual data value in the data set. That would happen if you have an odd number of data values. If the median is one of the actual data values, the rule is do not include it in either the upper or the lower half of your data set when you find Q1 and Q2. And the reason for that, we kind of exclude it from the upper and lower half, is that technically if the median is right in the middle, it's not in the lower half, and it's not in the upper half. It's in the middle. So if you have a median that is right in the middle, you do not use it to calculate either of the 2 quartiles.